In this video, we are going to explain about X-ray diffraction technique. Diffraction phenomenon. Diffraction is wave phenomenon in which the apparent bending and spreading of waves when they meet an obstruction. Diffraction only occurs with electromagnetic waves such as light and radio waves, and also in sound waves and water waves.
Light diffraction is caused by light bending around the edge of an object. The interference pattern of bright and dark lines from the diffraction experiment can only be explained by the additive nature of wave. Wave peaks can add together to make brighter light, or peak and a two will cancel each other out and result in dark. Constructive interference is the result of synchronous light waves that add together to increase the light intensity. Destructive interference results when two out-of-phase light waves cancel each other out, resulting in darkness.
Assalamualaikum everyone, I would like to present about my topic, which is X-ray sources. X-ray properties are defined as invisible, highly penetrating electromagnetic radiation of much shorter wavelength than visible light. As we can see here, the wavelength range for X-rays is from about 10 to the power of negative 8 meter to about 10 to the power of negative 11 meter. The corresponding frequency range is from about 3 times 10 to the power of 16 Hz to about 3 times 10 to the power of 19 Hz. The production of X-rays occurs when visible light photons and X-ray photons are both produced by the movement of electrons in atoms. When an electron drops to a lower orbital, it needs to release some energy in the form of photons. The energy level of the photon depends on how far the electron drops between orbitals. An X-ray tube is essentially made of two electrodes. The anode, which is made of a heavy metal of high melting point, and a cathode. When a high voltage is applied between the electrodes, streams of electrons are accelerated from the cathode to the anode and produce X-rays as they strike the anode. Next, I would like to explain about X-ray diffraction and Bragg's law. The diffraction of waves by crystals depends on the crystal structure of the wavelength. The structure of a crystal can be determined by studying the diffraction pattern of a beam of radiation incident on the crystal. Beam diffraction takes place only in certain specific directions. By measuring the directions of the diffraction and the corresponding intensities, one obtains information concerning the crystal structure responsible for diffraction. Bragg's law identifies the angles of the incident radiation relative to the lattice planes for which diffraction peak occurs. Bragg derived the condition for constructive interference of the X-rays scattered from a set of parallel lattice planes. W. L. Bragg considered crystals to be made up of parallel planes of atoms. Incident waves are reflected spectacularly from parallel planes of atoms in the crystal, with each plane is reflecting only a very small fraction of the radiation.
Hi, to continue this presentation, I am going to explain to you about d-spacing calculation and cubic crystal structure determination. Okay, first of all, what is d-spacing? D-spacing are the interplanar spacing that give rise to the X-ray diffraction peak, as we can see with the example below. Alright, next, d-spacing or interplanar spacing can be calculated by using the formula shown. The formulas are for each type of crystal structure, but for now, we are only going to focus on the cubic formula. For example, calculate the d-spacing for 013 chromium with A being 2.8849 angstrom. By using the formula that we saw earlier, we can obtain the d-spacing for 013 chromium as 0.9123 angstrom. Moving on, and now I am going to explain to you about the cubic crystal structure determination. The Mill index can be used to determine the reflection plane. The corresponding beam of n more than 1 can be used to determine the reflection of the statement of the nth order reflection from HKL planes. For example, the third order reflection for 111 plane is 333 plane. Now we are going to rewrite Bragg's law from the original into the second deviation, which makes the nth order diffraction of HKL planes of spacing d looks like the first order diffraction of planes of spacing d over n. Planes of reduced spacing will have similar Miller indices.
Hi, I'm going to explain about scanning electron microscopy. Scanning electron microscopy produces image of a sample surface by scanning the surface with a focused beam of electrons. The most common mode of detection is by secondary electrons emitted by atoms excited by the electron beam. The number of secondary electrons is function of the angle between the surface and the beam. The type of signal produced by SEM includes secondary electron, backscatter electron, characteristic X-ray. Secondary electron detectors are standard equipment in oral science, but it's rare that a single machine will have detector for all possible signals. The signal result will from the interaction of the electron beam with atoms at or near the surface of the sample. Backscatter electrons are beam electrons that are reflected from the sample by elastic scattering. BSE are often used in analytical SEM along with the spectrum made from the characteristic X-ray, because the intensity of the BSE signal is strongly related to the atomic number of specimens. Characteristic X-ray are emitted when the electron beams remove an initial electron from the sample, causing a higher energy electron to fill the shell and release energy. It is used to identify composition and measure the abundance of elements in the sample. Sample preparation. All samples must be in appropriate size to fit in the specimen chamber and are generally mounted rigidly on a specimen holder called a specimen tub. The sample is placed on stock and sputter coated with gold before SEM examination. Sputter coating is to acquire good result by providing a protective layer to the sample under high voltage of SEM. This is an example from sputter coating. This is an example of schematic diagram of SEM. You can see that there's a lot of components there. The electron beam is focused by one or two condenser lines. The beam passes through the pair of scanning column or pair of deflector plate in the electron column, which deflect the beam into the X and Y axis so that it can scan in a raster fashion over a rectangular area of the sample surface. Here is an example of SEM image that you can get.
Infrared spectroscopy helps chemists to identify the functional group present in a compound. It can therefore helping finding the structure of the compound. A pair of atoms joined by covalent bond can be thought of as being like balls in the end of vibrating spring. The bond can vibrate with different amount of energy at a frequency depends of masses of the atoms and the strength of the bond. Light atoms give higher frequencies, heavy atoms move more slowly and so give lower frequencies. Stronger bond give higher frequencies, weaker bond give lower one. At room temperature, most bond will vibrate the lowest possible amount of energy. But if radiation of the right frequency is applied, the bond can absorb energy and vibrate with greater amplitude. Most bonds absorb energy in the infrared region at the electromagnetic spectrum, which corresponds to heat. Each bond, such as OH, C double bond O, NH, and so on, absorbs at a particular frequency. This allows it to be identified. For historical reasons, and because the numbers are easy to work with, chemists dealing with IR spectra with unit called wave numbers.
Halo bosku, adakah? Ada sayang, ada.
All IR instruments have a source of IR radiation. This is a coil of wires surrounded by ceramic capsule which is heated electrically so it gives IR radiation. The IR radiation consists of 5 series of mirrors into the sample which is placed here in appropriate order. The radiation knob absorbed by the sample arrives at the detector situated here. Modern instruments such as this one use device called interferometer consisting of a beam splitter here and a pair of mirror at a right angle to one another. This produced is called interferogram from the source radiation. The interferogram holds information about the intensity of all infrared radiation of all frequencies simultaneously. This passes through the sample into the detector. The interferogram that derives the detector can be decoded by a mathematical technique called the Fourier transformation. This gives the intensity of the infrared radiation at each frequency separately. This transformation is handled by the computer and produces a graph of percentage transmission against wave number. The essential point is that pulses of infrared radiation crossing of range of frequency simultaneously pass through the sample and arrive to the detector. Some frequencies are absorbed more than others depending on what bonds are present in the sample. This is the sample holder. The sample is placed here on a crystal which made of diamond geogermanium. The IR beam is directed into the sample by a mirror. It is reflected back from the upper surface of the sample before being guided into the detector by a second mirror. This method is called attenuated total reflection or ATR. Here, the chemist is run the IR spectrum of solid benzoic acid. The instrument is switched on and the blank is run with no sampling place. This is to find the absorption of the air which must be subtracted from the data of the sample. These details of the scan is ran to the computer. The spectrum of the sample is obtained in a few seconds. The wave numbers of the most significant peaks can be labeled onto the spectrum. This helps the chemist to interpret the data. This peak is caused by a stretching vibration of C double bond O and this by the OH stretch. These two peaks together suggest that the sample may have carboxylic acid functional group. An unknown sample may be identified by matching its IR spectrum with a database of spectra of known compound, particularly in the region of spectrum below about 1500 centimeters to -1. The peaks in the area are due to the complex vibration of the whole molecule. For liquid sample, the procedure is the same, but you have to drop a liquid to place in this type of sample. The cover is to prevent the volatile of liquid sample.